All right, so isn't this beautiful? Aren't comets beautiful? I mean, they can be, and all comets look a little bit different. Can you imagine, years ago, ancient people, what they thought of when they saw something like this in their nighttime sky? And honestly, historically, they got real excited. But most comets we're going to see do not look like this. Most comets look pretty harmless. They look like a rocky, sort of icy object. So there is a comet in our nighttime sky right now, Comet Hergenrother. I think there are several comets, but this one kind of caught my attention, and someone pointed it out to me. And I actually, the other night at one of our labs in Keokuk, I went out and we saw this comet through the telescope. Now notice that this comet looks very different from the previous comet. This comet is mostly what we call coma. That's kind of the spherical region around the rocky part that is in outer space before it kind of looks like it kind of takes on a glowing sort of appearance. So comets orbit the sun, and so we will see comets move against the background stars. And so what Sky Telescope has here is a little map that we can see where is this Comet Hergenrother through for these particular dates in October. So this happened to be October 10th, so it was about right here. So this is the Great Square Pegasus, and this is that kind of corner star that kind of kicks off, and we have Andromeda kind of over here. But better yet, even since we have that go-to telescope, what Sky Telescope provided for us for the comet, this particular comet on the 10th, are coordinates. So we just tapped those in, and we got to see Comet Hergenrother. Looked kind of like this. I think if I understand it, this comet kind of surprised people. Didn't think that it would necessarily get as bright as it did. But it's kind of the nature of anticipating how bright comets will be. So most comets, like we talked about earlier, we have asteroids and comets are kind of the general things left over from the formation of the solar system. And comets are different from asteroids in that they form out in the colder regions of our solar system, beyond what we call the frost line. So they have kind of a rocky part of them and an icy part of them. So in that case, they're kind of like a dirty snowball. Most comets actually just kind of look like dirty snowballs. Most comets don't have kind of that coma region or a tail region. It's only if the comet gets close enough to the sun does that kind of leftover material, that dirty snowball, begin to go ahead and those ices vaporize, go straight from, they say sublimate, that go straight from being a solid to being a gas. So here's an example of a comet, and we're going to look more at this comet on the next slide. But what we have is, let me pull up my pointer here. What we have is kind of this nugget region in the center here. We call the nucleus. Nucleus. I don't think I have that term on the next slide. But that's the rocky, that's like the dirty snowball part that came from, was minding its own business in the cold regions of the solar system. It got a nudge, a gravitational nudge, maybe from Jupiter or another comet, and it got headed towards the sun and got close enough to the sun where you can see these gases coming off of the comet. And so it got close enough to the sun to begin vaporizing, and this is what it looks like. So in general then, we have this gas region right here called the coma. It's usually kind of circular. I mentioned that Comet Hergenrother, right now it looks like it only has a coma. And then depending upon the conditions, it can have up to 2 tails. The first of the 2 tails is what we call the plasma tail or ion tail. And it goes directly from the sun. Okay, it's not like a kite in that these tails kind of trail the motion of the comet. The tails, specifically the ion tail, will always be directed away from where the sun is. And we oftentimes can have this second tail called a dust tail. Okay, and the dust tails can be distinguished from the plasma tail, and they kind of have a curve to them. So I would just encourage you to visit NASA's sites. Be sure to like them if you go. And this is another one of NASA's great sites. Isn't this beautiful? This is, I think this is the Neat Comet. And notice that it's got, almost looks like it's got a kind of a secondary coma and kind of a stubby little tail. It's just gorgeous. If we go over in here to the gallery, you can see a famous comet, Comet McNaught. I can't remember what year that was, but maybe it says 07. And just gorgeous. Now, sometimes you have to be in the right, depending upon which part of the celestial sphere it's traveling through, you may or may not be in the right part of the Earth to see it. Okay, but night after night, you'll see the comet move against the background stars, just like we saw Comet Hergenrother move in the Great Square of Pegasus. So this is a good figure, I think. It does a good job. It shows you the comet orbiting the sun. Now, the comet can orbit the sun in general, I've read, about 100 times, depending upon the size of the nucleus. Okay, but every time it orbits the sun, and here's the sun down here, every time it orbits the sun, it is going to lose a little bit of itself. So here we go. Here's the comet, and when it's out here in the colder regions, notice there's no gas around it. Here we have the comet coming closer to the sun, and we see a bit of a gas kind of cloud. Looks like a little bit of a coma there. Here we see the comet pick up a little bit of a tail. Now it's got the two types of tails. It's got both the plasma tail and the dust tail. Now this is a good example. You see that even though the comet is going this way, you see that the plasma tail always has to point directly away from the sun. And here's the dust tail. And also notice then, as the comet gets farther away from the sun, it's cooler, and so we see less sublimation. We see, less of those gases. NASA sent a spacecraft. Actually, maybe it was a single spacecraft, but it had two components, called Deep Impact, and it visited Comet Tempel 1 in 05. And basically, and I'll just encourage you to look on the playlist for this chapter, for chapter 9, and I have these 3 videos, and yeah, I think it's very interesting. They had they got footage of the impactor, the thing that hit Comet Tuttle, and then they also had a camera hovering over the impact area so they could see what happened. And best I can tell, to a large degree, the matter that was spewed off of the comet during impact, actually most of that matter just kind of gravitationally settled back onto the comet. So pretty cool. All right. So we talked about meteors a little bit ago. We talked about a meteorite is a space rock that you pick up. A meteoroid, OID, is kind of like an asteroid, but it's smaller. It's like a rocky leftover. And a meteor, then, is where a meteoroid is a piece of rock is basically falling through the Earth's atmosphere, and it creates that streak. That's called a meteor. So meteors do not last very long. And so meteor shower are times of the year where the Earth is passing through an unusually large amount of meteoroids. Okay, so what does that have to do with comets? Well, everything. So I don't know if you can make it out real well, but this line right here is showing you the path that a comet is taking as it orbits the sun. This path down here is showing you counterclockwise, is showing you the path that the Earth takes as it orbits the sun. One of the things we said about comets was that as they get close to the sun, they vaporize, and they also leave some of their rocky material. So rocky material from a comet. Think meteoroids that the Earth is going to run into if these two paths, the path of the comet and the path of the Earth, intersect. Now, during a meteor shower, the Earth is not crashing into the comet. During the meteor shower, the Earth is passing through where a comet has left its debris. Meteor shower. And these will happen characteristically at a certain point in Earth's orbit about the sun, which means they happen during a certain year, during a certain month at a certain time. So this is, I don't think this is a photo, although there are some really cool photos out there of meteor showers. Maybe it is. But what will happen is we'll see the meteors tend to all come from, those streaks all come from a common central point we call a radiant. Radiant. Okay? Because that is the intersection of Earth's orbit intersecting with the comet's orbit. So, let me see. Well, I guess I don't think I have a current list. Okay. For instance, we have here in a week or so, we have the Orionids coming up. Orionid meteor shower. And what that means is that within the constellation Orion, we are going to see the radiant. Okay, that's what the Orionid meteor shower is. The Geminids, we see it in constellation Gemini. The Perseids, the constellation Perseus. Okay, so that's generally how that goes. So if you've ever kind of pictured yourself on like driving down the road and on a snowy night, and you can kind of see, it's almost mesmerizing. But that's kind of what we have with regard to the Earth passing into or through, I guess I should say, debris that was left by a comet. And again, this list of meteor showers, I'm pretty sure is 2011. Let me click it. But I will go ahead and make available from the website. Yeah, I think this is last year's meteor showers. This year, but it's last year's, but it does a similar thing. So like down here, number 40, you see 40, December 14th, the Geminids, constellation Gemini. Now, one of the things you want to, if you're trying to decide whether or not to try to catch a meteor shower, is you need to look at, well, how many strikes or meteors per hour would I expect? 60 per hour is a lot. That's about 1 a minute. Go back here to this famous one in August, August 10th, okay, 50 to 100 meteors per hour. Is that crazy or what? The other thing about meteor showers in general is that the darker the moon actually needs to be pretty darn dark, near a new moon, or even like a first quarter, because it would set pretty soon. You need to have dark conditions to see these meteors. And the other thing is, in general, the meteors it needs to be like after 11 p.m. or so for some of your best seen. But meteor showers can be really cool.